part, but it's okay. We'll just wing it. All right. So for 10D, for this question right here, where it says approximately when will the acceleration of the particle equal to 0, you need to ask yourself, what is the relationship between the acceleration and this graph, right? So if this right here, the position function is given by the integral of this f of x, that means the derivative of that would be f of x, which is the velocity of the function, right? And that's how we answered the question for part C. What is the velocity of the particle when t is equal to 5? We just have to look at the graph and say, oh, the function itself at 5 was equal to -2, so therefore the velocity is equal to -2. For part D, the acceleration is the next level of your derivatives, right? So if I take the derivative again of this f of x, f of x, it's going to give me the acceleration, which basically means you're looking at the tangent lines, right? So the tangent lines of this is going to be the acceleration. So I have negative acceleration here, all the way till it's going to equal to 0 when you have a critical point. And that critical point looks like it's going to happen at about right there. You guys see that? Right at t equals to 5, it looks like the acceleration hits 0 because it goes from a negative acceleration and then it goes to a positive acceleration, right? Since it goes from a negative acceleration to a positive acceleration, I'm going to say that the acceleration is equal to 0 at about, right, t equals to 5. That's it. At about t equals to 5. All right. Does that help you out, Fatima? Hopefully it does. Hopefully that kind of makes sense, right? And for part E, right? For part E, at time approximately during the first 7 sections, man, not only does that have a typo, I just read that horribly wrong. At what time during the first 7 seconds does S have the largest value, right? The largest value of S occurs when V changes signs from positive to negative. And if you think about it this way, right? Remember, S is equal to the integral from 0 to t. Well, if you think about it, integral of a function is basically asking you to find the area of said function between the function itself and the x-axis. So at right about here, at about 3.5, I don't know if you can see that, this right here, this part in yellow would be equal to S. Now, once you go past 3.5, you start getting negative area. You see this? This is all negative area, all the way up to 7. So negative area would take away from your area when you start summing it up. Does that make sense? So the reason why S is going to be the largest up until about t equals to about 3.5 is because it's all positive up until there. You see that? It's all positive up until there. These are all positive areas up here. And you're just going to be summing them up when you do the integral of it. Once you get past 3.5, those areas start to get negative and you have to start subtracting them, right? That's why if you look at the video and you take a look here at number 6, right? If you take a look at number 6, you should have gotten 2 different answers here, right? For part B, you're going to get an answer for this one from 0 to 6. But then when they ask you for the area of the region between the graph and the y-axis, we needed the positive value of that. So we took the absolute value of this part. And that's basically what's going on here. They're not asking for us what's the area there. They're asking for what's the value of S. And if you think about it, if you have a particle has a velocity this way, right? He'll be further away from where he's at. And then once his velocity goes negative, he starts to go backwards. So he starts to head towards his origin. So he's not as far away anymore. He starts to travel backwards. Does that answer your question, Monica, about this one? Hopefully it kind of does. It kind of makes sense about areas being added together and why this is the greater part. Yeah, hopefully that does. And then Leslie's asking for if I can go over number 8. Of course I can. We can go over number 8. Let me double check how much time we have left here. 33, 10, 15. Perfect. I got 15 minutes. Let's go over number 8. Let's go over number 8. I did not go over number 8 before in the video, so this is perfect. Let's go over number 8. Let me get number 8 copied and pasted here. Where are you, number 8? Number 8 involves the trapezoid rule. We call the trapezoidal sums, trapezoidal rule, trapezoid everything. Let's take a look at this. Use trapezoidal sums with 4 trapezoids of equal width to approximate the value of the integral from 1 to 5 of 4 minus x squared dx, right? So that's not too bad. That's not too bad, right? 4 minus x squared. You don't need to do this, but whenever I have to deal with the trapezoidal rule, I like to graph it out. You do not need to graph it out ever. You can just create a table. A table works as well. But for me, for me, this is just a personal thing. I like seeing it graphed out because it just makes it easier for me to visualize it, right? So this is going to go from here's 0, here's 1, 2, 3, 4, and 5. And they want 4 trapezoids from 1 to 5. So I don't know if you can visualize it, but just drawing this out already helps me to see, here are my 4 trapezoids, right? Here are my 4 trapezoids. That's one trapezoid. That's another well, those are just lines, but they're going to be the bases of my trapezoids. There are the 4 bases of my trapezoids right there. You see that? And I'm going to draw this out. It's going to look something like this. So 4 minus x squared looks something like this, I believe. I think it's supposed to curve down, so my drawing is a little bit terrible here. It looks something like that. I think it crosses at 2 though. So I'm gonna make it like this. Something like that. Right? And then I just need to draw my trapezoids here, right? So it's gonna be, this is my first trapezoid right here. My second trapezoid is gonna be from here to here. My third trapezoid is gonna be from here to here. And my 5th trapezoid is going to be from here to here. So I just need to get these values to calculate these areas, and then you just add them all up. Would we have to find the area as well? That's all. That's exactly what you're doing. You're going to be adding them all up. Oh, for 10E. No. For 10E, Monica. I'm sorry, I just barely looked back at that question. For 10E, you do not have to. You just need to state where it would possibly be. And why, I believe that's all it's asking for, right? Does it even ask for the y? Doesn't even ask for the y. Doesn't even ask for the y. So yeah, you don't have to do that. Leslie, does what I have drawn make sense so far? For number 8 right now. This is the trapezoidal sum. It does? Awesome, awesome. So now we just go ahead and calculate the area of each trapezoid, right? So this right here, the integral from 1 to 5 of 4 minus x squared dx is going to be approximately, and we just do each of these trapezoids. So the first trapezoid, right, is going to be 1/2. The base one is going to be this guy. I need to calculate this, right? I need to calculate this out. So this right here is going to be 4 minus 1 squared. 4 minus 1 squared, right? Which is just going to be equal to 3. Plus, this one right here is going to be 4 minus 2 squared. How do I know it's 4 minus 1 squared and 4 minus 2 squared? Those are the x values that I'm plugging into this function. And that's how it's going to tell me what this base is, basically, right? And then this next one over here, 4 minus 2 squared, that's going to equal to 0. And this has a height from here to here of 1. So that's going to be 1 right there. And we do this for all 4 trapezoids, right? We do this for all 4 trapezoids. So this right here is going to be plus 1/2, and then we'll do the next one. This right here, we already calculated it. This is going to be 0, plus I need this one over here. This one's going to be 4 minus 3 squared. 4 minus 3 squared is going to give me a negative, I believe, a negative 5. Negative 5, I believe, right? And this, of course, is multiplied by 1 as well, because from here to here is equal to 1. And we just keep going with this. We keep going with it. The next one up is plus the purple one, right? The purple one is going to be 1/2 negative 5, because we already calculated that right here. Plus this one right here, this one's going to be 4 minus 4 squared. And that's going to be a negative 16. Plus 4 is going to be negative 12. Again, times the distance from here to here is 1 as well, right? And that's all we do. We do this for all of them, and we just sum them all up. Last one right here is going to be plus 1/2 of, that last one was negative 12, plus this one down here is going to be 4 minus 5 squared. Negative 25 plus 4 is going to be like negative 21, I would say. And then again, this height from here to here is 1 again. And there you go. And then you have to just sum them all up, divide by 2, and then add them all together. And that will give you your area, which in this case, it looks like it's going to come out negative because a majority of your area is going to be on the negative side, right? The majority of your area is going to be on the negative side. That is some ugly highlighting that I'm going to do there. I'm not going to do that. But does that, hopefully that makes sense, right? You're going to calculate it, the area here. These are all going to be negative areas. Your answer should come out to be negative as well. If you want to double check your answer, I think it's going to come out to like negative 26. I could be wrong, but it should be around there. Around there. All right. That was number 8. If you guys haven't done this already, right, you guys should have a couple of these. Can you do an example of an integral property from the delta math? Of course, Brian. And thank you for asking. I was going to say we're going to have to sit here quietly, but no, you guys came prepared and ready with questions. Let's see the integral properties. Let's click on that one. I should not be showing you. I should not be putting that on the screen. That just shows everybody's attempts. Let's take a look at this. Let's take a look at an example here. I'm going to screenshot it, and then I'm going to put it onto mine. Let's take a look at this problem. Boop. And let's put it onto here. Boop. All right. Let f be a continuous function such that the integral from -1 to -5 of a function is equal to -9, and the integral from -1 to 2 is equal to 6. Find the value from -5 to 2 of 4f of x. This one is a little bit annoying in a sense that one of the things they give you is out of order. I don't know if you can see it, but normally when you do integrals, right, from a to b of f of x, normally and traditionally, you want your a to be less than your b. That's how we normally want things set up. It's just easier to read that way. And this one's good right here. This one's good. It goes from -1 to 2. That's awesome. What I don't like is this one. I don't know if you see this. I don't like this setup. Let me close this. My OneNote is just, it lags whenever I copy and paste. So give me a second here. So I don't know if you see this right here, but this one I don't like. This one right here. It's going from -1 to -5. Why don't I like that? Yeah, Brian, that's exactly it. I wanted to go from -5 to -1 instead. I want to write this out as the integral from -5 to -1, because from -1 to -5, that's backwards, right? I wanted to go from smallest to greatest. So from -5 to -1 of f of x dx, that's going to equal to just 9. And that's one of the properties. If you switch these numbers around, you just switch the sign of your answer. Okay, so that's the first property you need to know. When you switch the values of your integrand around, that doesn't sound right. The limits of your integral, no. The value, oh, knock me, you should know the names of these guys. They need to be, if you switch those around, you switch the value of your answer as well. So this is the first step. This is the first step you need to do. The integral from -5 to -1 should be equal to 9. Okay? Now, why do I care? Well, first of all, take a look at this. What they're asking from us is going from -5 to 2. This goes from -5 to -1, and this one goes from -1 to 2. So I can combine those two together. I can say that the integral from -5 to 2 of f of x dx is the same thing as the integral from -5 to -1 of f of x dx plus the integral from -1 to +2 of f of x dx. Are you following along here? Why do I care? Because I actually know what the value of this is. You see that? I actually know what the value of that is. And I know what the value of this is right here. So I can actually plug those in. So the integral from -5 to 2 of f of x dx is equal to 9 plus 6, which would be equal to 15. Now we're not done. I know that seems ridiculous, like you just did so much, but you're not done because they're not asking for the integral of just f of x. They're asking it for 4 times that. And basically all you have to do is once you figure out this, the integral from -5 to 4 times f of x dx, the property that, another common property is that you just take the 4 out and multiply with it. So it will be 4 times the integral from 5 to 2 of f of x dx, which is just equal to 4 times 15. And this is going to equal to 60. And that's it for this problem. The properties one is a little bit strange, but it is one that you do need to know. The most common properties that you should know offhand is when you switch the a and b values, it switches your outcome. The constant property, which is basically if you have a number that's here that's multiplying your function, you can factor that out and just do what's inside and multiply by 4 later. And the last but not least one is the summation of your integrals. The summation of your integrals. There's other properties in there, and there's other properties that were in your homework, but these are the major properties that you need to know. The constant property, the summation property, and the the switching of the, there's a name for this, knock me. I'm drawing a blank on my names right now. But yeah, that's pretty much it. Was it? Where did I put that? Did I cover these in the notes somewhere? I should have, right? These properties. Didn't I cover these properties? I should have covered these properties. If not, I did a terrible job of. Is it here? No, that's not it. I forgot where I put him. Was it in the trapezoidal rule? No. No. Oh, well. Yeah, I swear I remember what I did. I just don't remember where I put them. Anyways, it's in the homework for sure. The properties are in the homework for sure. And also the video that they have on Delta Math should cover those properties as well. But yeah, that's that one. Anyways. With that being said, if you still have questions on stuff, please send me an email. I do have a meeting today until 3, but your test is tomorrow on this. So send me an email if you have any questions about your test tomorrow. But yeah, it shouldn't be too bad. It should be just all these integral problems and trapezoidal rules and all that whatnot. But yeah, that's going to be it. I'm going to go ahead and stop the recording here and call it a day. If you have any questions, send me an email about it. Because I do have, like I said, I can't have office hours today, but I can try my best to answer before your test tomorrow. So the sooner the better. If you send it at 10, I'm not going to answer it in time. But if you have any questions, just let me know. Okay? All right.